Hello there, ROS developers, and welcome to a new open class. Today we are going to have a very interesting class where we are going to explore how to easily create web dashboards for our robots. All right. So first of all, before getting started, let me ask as always if everything is fine, if video is fine, audio is fine. Let me know if everything is correct so that we can continue normally. Let me know here in the chat. Okay, I can see Sonia there who says that everything is fine. All right. Okay, then I guess that we are ready to get started. So let me go ahead and start straight sharing my screen. So let me switch already here and go to the live class page so that I can have your comments in here. Let's see. I should have, there we go. Okay. All right, we can see Beer Winder here also saying that everything is fine. Hello, Beer Winder. All right, so as I was saying, today we are in class number 196, and the topic for today is going to be how we can easily create a web dashboard for ROS 2, okay? And during this class, we are going to show step by step how to build it. And you will see the goal for today's class is to end up with a basic web dashboard for our robot, which in this case is going to be a LIMO robot, okay? Which if you have been attending to our previous classes, you should already be familiar with it. Sorry. So, without further ado, let's get started. And the very first thing that you need to do before we get started with the class, as always, is to get a copy of the project for this class. These projects, we call them ROSjects because they are basically self-contained ROS projects, okay? And why I want to share these ROSjects with you? Well, because these classes are meant to be interactive, all right? So while I am going to be explaining and showing the different examples that we have for today's class, you can at the same time practice also in real time. In fact, that is what you should do, okay? So I don't want you to be there just listening and watching to what I am seeing. Then you might be asking, okay, Alberto, very, very well, but how do I get this project? Okay, very easy. All you have to do is to click on this button that appears here right above the chat. Which says fork and open the class project. If you click here, this is going to, let me click myself here because I also am going to get a copy of the project. There we go. Okay, so as you can see, first of all, you are going to be redirected to this page, which is basically the main project page, okay? And here in the right side, you are going to have the streaming panel, the streaming area, okay, with the video, the chat, in case that you want to write questions, comments, whatever. Okay, in my case, I'm going to move this out of my screen so that I gain some more space here for my main project. This is going to take some seconds to fully load. And once it loads, as you can see, what you should get is the notebook for today's class automatically opened, as I have here in my case. So this is the notebook for today's class where we are going to have all the instructions, example codes, step-by-step guides. Everything for today's class is here in the notebook. All right? Then let me, meanwhile, open here the chat again so that I can still see your comments and everything. There we go. Okay, so first step finished, is to get a copy of the ROSject and load the ROSject environment so that you have basically the notebook here available, okay? This is what we are going to be following for today's class. Now, when you click on this button, not only you are going to be redirected to the ROSject page, like you can see here, but also a copy of this ROSject is created in your account forever, okay? This is a permanent copy. And you can access to this copy very easily here in the left menu by going to the My ROSjects section. I'm going to open it here myself. And as you can see here, a copy of the ROSject is generated. Okay, so you are also going to have this copy in your account. And basically, this is useful because you are going to have access to this project, not only for today's class, but basically for whenever you want. Yeah. So if, in case that you want to go back and open this project next week, next month, to review the materials, whatever, you are going to be able to do so. Okay. All right. Then have you been able to copy and properly load the project environment? Everybody in the chat, please let me know, so that we can get started and we are all together in the same page. Let me know here in the chat. Okay. Sonia says that she can open it. What about the rest? Berwinder, have you been able to load the project like me? Okay, so no more comments for now. Then I'm going to assume that everything is fine and nobody is having problems. Okay, then yeah, so let's continue. Yeah, now Berwinder confirms yes. Okay, then let's get started. So first of all, you might be asking, okay, so how to create a web dashboard for ROS2, right? This is the topic for today's class. But why should I create a dashboard, first of all, right? Why should I care about creating a web dashboard for my robot? Yeah, you might be asking this right now. Then, well, imagine the next scenario that we introduced here at the beginning of the topic. Yeah, so imagine that you have built your own robot from scratch. You have a super cool robot working, or maybe you have programmed already an existing robot, okay? And then you know how your robot works, right? So if you have been creating a robot from scratch, or you have been creating some software for a specific robot, you have been developing it, so you know perfectly how your robot works, right? So you are going to be able to launch your robot and maybe use RVs in order to visualize the laser data, the camera, yeah, and verify that everything is okay or is at it as expected, right? Now, you have to bear in mind that you are a developer. You are a robotics developer, yeah? But the end clients of your robot might not be robotics developers and might not be actually into robotics at all, okay? So your end clients don't have to know how to use RBs for instance, in order to debug if your robot is working as expected or not, right? Then for this, yeah, so you hand off your finished work to your client. Yeah, let's say an industrial robot in a factory or a service robot in a restaurant. Yeah, so you demonstrate that your system works and you go home happy. But the next day you get multiple phone calls. The robot is out of control. I don't know how to operate it. Yeah. So what happened in this case is that while you understand how the system works and how to monitor the robot visually, for instance, through RVs2 or through command line tools like work to topic list, etc., the end client, actually most people, but the potential end client are non-technical users, which are more accustomed to working with dashboards and one-click tools. Yeah? This is why most commercial robots, come with web dashboards, allowing operators to easily control the robot's core functions and view diagnostic information such as error codes without needing to rely on development tools like RVs2. Yeah? Yeah? So the goal, the main use of having dashboards, having web dashboards, or dashboards in general, is to make the life of your potential clients, the people who is going to use your robot, much easier. Yeah, they don't need to know about robotics development in order to use your robot. Yeah, does it make sense? This point, do you agree on the importance of web dashboards? Yeah. Okay, so this is what we are going to be exploring for today's class. All right? Then the goal for this open class is going to be the following. We are going to develop a web dashboard for a LIMO robot. Yeah? And in order to achieve this goal, we are going to be using some tools such as rosbridge and roslibjs, which we are going to explain in a moment what these are. Okay? But let's get started. Yeah, so before we start creating our dashboard, we actually need a robot, right? Then for this, we are going to use a simulated version of a LIMO robot. Okay? Yeah? Then let's start our robot simulation. And for this, we first of all need to open a terminal. Okay, actually not this. This is the code editor, yeah? But we need to open a terminal by clicking on this, the very first icon that we have here in the bottom menu in your project, yeah? Which says Web Shell. If you click here, this is going to open a, so you can see a blank terminal, okay? Now, in this terminal, we can copy and paste these commands, which are going to allow us to start the LIMO simulation. Okay, so let's copy these commands directly here from the notebook, copy and paste into the terminal. There we go. Okay, now we should wait some seconds for all the simulation processes to come up. And if everything goes okay, we should see automatically pop up here in the project window, as you can see here, this simulation, okay? So let me go back here. Let me maximize this a little bit, and there you go, okay? This is the simulated environment. Yeah, actually we can zoom in here to the center, to the robot, yeah? And here you are going to see that we have this small room, let's say, with the LIMO robot right here. Yeah, this is the LIMO robot. The robot for who we are going to be creating our web dashboard. Okay? Yeah? So far, so good. Has everybody been able to launch the LIMO simulation properly? Yes, no? Please let me know in the chat. Any problems, any issues so far? Is everybody following until this point? Yes, no? If nobody says anything, I'm going to assume that everything is fine. Are we good? Okay, Birwinder says yes. Okay, then let's keep going. Let's keep going. Okay, so now that we have our robot here in a simulated environment, let's start to create a web dashboard for our robot, right? Then, for this, we are going to be using a tool which is known as the rosbridge server, okay? And what is this rosbridge server? Well, in simple terms, the rosbridge server provides a bridge between ROS2, in this case, we are working in ROS2, and web-based or non-ROS applications, yeah? In our case, we are going to use the rosbridge server for bridging a ROS2 system, which is our robot, with a web-based environment, which is going to be our dashboard, okay? But the ROSbridge server can also be used to bridge between ROS2 and non-ROS applications, other kind of applications, okay? For instance, a mobile phone application, yeah? And then this enables us to send and receive ROS messages over the web, yeah? Then how this works is that the ROSbridge server creates a WebSocket connection, which allows bidirectional communication between the robot, between the ROS system, in this case, and web browsers. Yeah? So the ROSbridge server is going to expose ROS topics. Yeah? Then, for this, first of all, we will need to install the ROSbridge server into our system, okay? Then, in order to installing the ROSbridge server into our system, we can run the following command, okay? So let's go back to our terminal, to our shell. Here, don't worry if you see some red messages, it's okay. Okay, you can ignore it. As long as you have your simulation here, it's okay. You can ignore these red messages, yeah? Then we are going to leave our simulation running here in the first terminal, and we are going to open a second terminal by clicking here in the plus icon, yeah, which says create new terminal. Yeah? If we click here, this is going to open a second terminal so that we can run other commands here without terminating or closing the first one. Yeah? Then in this second terminal, we are going to copy and paste the command that we have here. Yeah, so it's sudo apt install ROS humble ROSbridge server. We click enter, and here you are going to see that nothing has been installed, basically because the package is already the newest version. Yeah, so in this environment, in this ROSject environment, we already have the ROSbridge server package installed. Okay, in case that you want to use it, you would need to install it in your systems. Okay, yeah. Then step number 1, install the ROSbridge server. Step number 2, running the ROSbridge server. So for this, we can run the default launch file provided with the ROSbridge server package, which is this one here. Yeah, we can do this very easily with this command: ros2 launch ROSbridge server main ROSbridge launch.py. Okay. By executing this default launch file, we can start the ROSbridge server in our system. Okay? There we go. Yeah, if everything goes okay, you should see a message like this one saying, ROSbridge web server started on port 9090. Yeah? So right now, I have started here my ROSbridge server. Yeah? Okay, so step number 1 covered, which is, well, actually step number 2. First one is to have a robot, right, which we have our LIMO robot here simulated. Step number 2 is to run the ROSbridge server, which we also have running here in our second terminal, okay? Now, we are ready to start creating our web dashboard, okay? So for this, we are going to go to the code editor and create a new file. So for our web dashboard, we are going to be using basic HTML and JavaScript, okay? And also a bit of CSS for styling, yeah? So what we are going to do is to go to our code editor, which you can open by clicking on this icon that is down here, code editor, yeah? And you are going to see here you have the web page workspace folder. So inside here, we are going to create a new file named index.html. Okay? There we go. Yeah, so you should have something like this. Okay? And then let's start by creating, adding something very simple to our web page, which is just a header saying hello construct. Yeah. Then for this, you can again directly copy the code here from the notebook and paste it into the index.html file. Yeah, there we go. So we have created our very, very basic web page here. Now we need to be able to visualize this web page, yeah? So for this, what we are going to do is to launch an HTTP server, okay? Yeah, and we can do this with the following commands that we have here, all right? So let's go again to our web shells here, and let's open another one, a third one, okay? Just for clarification, we can rename our terminal. For instance, if you click here in the tab, yeah, you can rename it. Let's say this one is the simulation, so put it to sim. Second one, I'm going to rename it to rosbridge, right? Here we have rosbridge running, and then here we are going to put the web page, yeah? Web page, okay? Then in this third terminal, we are going to go inside the web page workspace, first of all, yes, cd web page workspace, where we have our index.html file, and then we are going to start here the HTTP server with this second command. There we go. Okay, so here we are serving our web page, yeah? And then final step is to visualize actually in our web browser this web page, yeah? So for this we need to get a specific address, which we can get very easily by using this web page address alias, okay? For instance, if you were working in a local environment, your web page would be here, yeah, in this address, http 000 yeah? In our case, however, since this is a cloud-based environment, we need to use an alias, okay, for this. But don't worry, because this is very easy. All you have to do is to open another terminal here, and then execute the following command, yeah? Web page address. We paste this here, yeah? And then this is going to return, as you can see, an URL. And then we can directly click on this URL, and this is going to open our web page. So here we can see our first version of the web page with a header saying hello construct, yeah, which is what we have added right here. Okay, so we have our very first version of the web page running. Okay, so far so good. Have you guys been able to follow me on my steps? Is everybody able to visualize the web page here using the web page address URL? Yes? No? Yes, here. Okay, excellent. Okay, we have also Kevin Medrano saying yes, and also, I guess this is Chinese. Sorry, but I don't know how to read Chinese letter. I hope I did, but not so far. But yeah, basically I see that everybody is following. Excellent. Then let's continue, because you will agree with me that this is not actually any web dashboard for a robot, right? Then let's start creating our web dashboard. Okay. So what we need to do right now is to actually connect our robot with our web page, yeah? Because so far we are not connecting anything, yeah? We are just showing some letters here, yeah? So we need to establish a connection, yeah? A communication bridge between our web page here and our robot here, yeah? And for this, as I was saying, we are going to be using rosbridge and roslibjs, yeah? So these are the two main actors in establishing this connection between between the robot and our page, and our web page, yeah? It's roslibjs and the rosbridge server, okay? The rosbridge server, we already have it running here, right? In our second terminal. And roslibjs, we are going to use it from the web page side, okay? In a moment, I'm going to clarify a little bit about this, okay? But for now, let's start. So let's add some things to our web page, okay? First of all, we are going to create a basic structure, which we can see here, yeah? So let's copy this code, and let's go to the code editor and update our index.html file, okay? Like this. So, very simple, yeah? So we have just a header with some metadata, the title, and a body, yeah? A body for our webpage where we are specifying some very basic CSS style, okay? And then we have the body tags where we are going to put basically the body of our dashboard, yeah? Then here we are going to need to add some things, yeah? First of all, we are going to import the roslib library, yeah? Which we can do with the following line, okay? Second, we are going to add to our web page a connection form, okay? Basically, this is going to be an input field with a button, yeah? In the input field, we are going to ask the user to enter the rosbridge address to establish the connection with the robot, yeah? And then we are going to provide a button in order to connect to the robot using the provided rosbridge address, okay? We are going to also add a bit of CSS, a bit of styling to our connection form. And finally, we are going to create a function. We are going to define a JavaScript function for when the user presses the connect button, yeah? As you can see, whenever the user presses in our connect button here with the on click, this is going to call this connect to ROS function, yeah? So we need to define this function, and this is what we are doing here, yeah? And within this function is where we establish the connection with ROS using the rosbridge address provided by the user, okay? Then, when establishing these connections, basically we have three possible results, yeah? The connection is successful, in which case we are going to print a log message. We have an error in the connection, in which case we are going to show another message, and the user closes the connection, in which case we are going to show another log message. Okay? Yeah? So all this together, all this together is going to end up in something like this. Okay? So let's copy this updated index.html here and paste it into our page. Okay? Let me make this a little bit bigger. Yeah? So far we should have something like this. Yes, we have our head where we are importing the roslibjs. Yeah? We have some styles here for the body and for the connection form. Yeah? And in the body of our web page, we have the input field with the button to connect, and then we have the definition of the connect to ROS function for when the user presses the connect button. Okay? Then let's update our web page. Let's go to our web page and refresh. And now we should have something like this. Okay? Yeah? So we have our ROS web dashboard with an input field and a connect button. Right? Yeah? Is everybody following? Have you been able to create this updated page? This is very important because this is going to allow us to establish the connection with the robot. Okay? Yes. Okay. Okay, excellent. Then let's continue. Let's continue. So what should we input here then? What we need to input here is the address where our rosbridge is running, okay? If we go here to the rosbridge, to the terminal where we have rosbridge running, yeah, we can see that here, rosbridge WebSocket server started on port 9090, okay? So we have here a port. However, here, again, this is a special environment, so we are running in a project, right? If you were working in a local environment, probably it would be enough to input something like this. Yeah, WebSocket localhost 2.9090, which is the port, right? In a local environment, this would be enough. However, since we are in a project, again, we need to get an alias address for this. Yeah, and you can get this very easily by typing in a terminal rosbridge address. Yeah, if you execute this, you are going to get the rosbridge address for your specific project. Yeah, so then you can copy this address like this, right click, copy, and paste it here into the input field. Yeah. And then here you can press the connect button. Yeah. Here, as you can see, we don't have any feedback here. So in case that you want to see some feedback, by feedback I mean these console error, console log messages, yeah? For this, you can open the developer tools, okay? So you can come here and, I don't know how to open the developer tools here in Windows, actually. I'm not used to, let me see if I can see. Damn, I don't know how to open the developer tools in Windows. I'm not used to work in Windows systems, so let me see if I can find it here. More tools. Probably it's here. Okay, there you go. There you go, yeah. So here we can go to the console, see? And we can see the message being printed. Connected to rosbridge server. Yeah? So here now the connection was closed. Yeah? So if I press again here in connect, yeah, connected to rosbridge server. Okay? Yeah? Then, what is roslibjs? Yeah, so what is this roslibjs that we are using here, roslib, for establishing the connection, yeah? So basically, roslibjs allows the web dashboard to communicate with the ROS system via the rosbridge server, yeah? So specifically, it provides an easy way to interact with ROS topics, services, and parameters through a WebSocket connection, which allows real-time communication between the web page and ROS. Yeah? So how do they work together? Well, you can think of the rosbridge server that runs on the ROS machine and opens up a WebSocket connection to which clients can connect. Yeah? So the rosbridge server runs on the ROS site. And roslibjs is the client that is running in the web page site. Yeah? So we have the rosbridge server on the ROS site and the roslibjs on the web page site. Yeah? So roslibjs is used on the client side in the web browser, in this case, to establish a connection to rosbridge server and interact with the ROS system. Yeah? It translates user commands into ROS messages and receives ROS data via WebSockets. So, in short, roslibjs is the client-side library that you use to write JavaScript code to interact with ROS, as you can see here inside the script tag. Yeah? And rosbridge server is the ROS site server that enables external non-ROS clients, like a web browser, to communicate with the ROS system. Okay? Yes, so this is how everything goes together. We have our robot here. yeah, which has all the ROS systems. And then here we need to place a rosbridge server, yeah, in order to provide this server for others to communicate, yeah. And then from our web page, we run the roslibjs client, which connects to this rosbridge server and exchanges information about ROS, yeah. And then in order to establish this connection, we have created this button here, yeah. Is it clear so far? Is it clear? Has everybody been able to establish the connection between the web page and the ROS robot? Yes, no? Let me know. Kevin says clear. Okay. Excellent. What about the others? Is it clear? Have you been able to follow? Yes, no? Okay. I will assume that yes, that so far everything is clear and it is working on your side. Okay, then let's continue. Let's continue. Because, okay, so now we have been able to see how to establish the connection between our robot and our web dashboard, okay? But still we don't have anything here in our web dashboard, okay? So let's start. Let's start and let's see how to get data from a topic, yeah? So for instance, if we come here and we run a ROS2 topic list, we are going to see that our robot provides multiple topics, right? We are going to see here in a moment. Let me run it again. Yeah, so we can see here some topics related to the camera, command belt topic, yeah, for velocity commands, a topic for the IMU, joint states, another topic for the telemetry, yeah. So all these are topics that our robot provides. So how can we interact with these topics or get data from these topics into our web page? So for this, we are going to start by a very basic example, which is displaying the position of the robot in X and Y. Yeah? Now, we know that the position information of the robot is provided by what topic? By the odometry topic, right? So if we do an echo here, ROS2 topic echo of the odom topic, to change the keyboard here, of the odom topic, this is the odometry topic, and this topic is the one providing information about, as we can see here, about the position and orientation of the robot, yeah? So if we want to display into our dashboard the position of the robot in X and Y axis, what we are going to need to do is to basically get the information, which we have actually here, position in X and Y, and we need to get information from this odom topic, yeah? So for this, we are going to create a new function inside our connection, yeah? So when we connect to the rosbridge server, we are going to call this setup topics function, yeah? And then inside this setup topics function, we are going to define this odom topic, yeah? Then in order to define a new topic, we need to provide the ROS connection, the name of the topic, and the message that this topic uses, which in this case it's nav messages odometry. Okay? Then once we have the odom topic defined, we can call the subscribe function here in order to subscribe to this topic. Yeah? And then from this topic, we are going to get the value of the position in X and the position in Y. Yeah, this is the pose position X, pose position Y. This is exactly this, yeah? Pose position X and pose position Y. Yeah? So we are getting the information of the position of the robot in the X and Y axis, and then we are displaying, yeah, this information in two new elements of our web page, which are position X and position Y. Yeah? Then, once we can capture this information and display it in elements of our web page, then here what we are doing is to basically add these elements. Yeah? We need to add the elements of position X and position Y where we are going to be displaying this information. Yeah? And then finally we provide some CSS styling here. Okay? Yeah? So the final result is going to be this. We have here the full web page. So again, let's copy the final result here. Let's copy the web page code and replace our current page. So let's remove our current page and paste the updated code. Yeah? So we have the styles. Yeah, remember. Then here, as you can see, we are adding the new elements for showing the X and Y position of the robot. Yeah? And inside the JavaScript section, here inside the script tag, we have added the setup topics where we are defining our ODOM topic, we are subscribing to the topic, and we are getting the information of the position in X and Y and showing this information in the position X and position Y elements that we have defined here in our web page. Yeah? So let's refresh our web page here. Let's go and refresh. And as you can see now, we can see here the position panel with the values X and Y. Yeah? Now, if we want to connect to the robot, again, we need to paste the rosbridge address. So let me do this. Let me copy and paste again the rosbridge address. And now we should see these values updated to real life. Okay? So now, as you can see, this has changed because now I am getting the real values of the robot. Yeah? So if we check here, we can see that the X is this is a 0, basically a negative exponential, and this is minus 0.9. Yeah? Furthermore, we can move a little bit the robot. We can move a little bit the robot with the following command, with a teleop keyboard program. Yeah? So let me copy this command from here, run it here in the free terminal. Yeah? And then this is going to allow us to move a little bit the robot. For instance, let me move it a little bit forward. This is the y-axis. And then if we go back to the page, we are going to see how this value is updated. Okay? Yeah? There we go. Okay? So now we have our web page, which is connected to the robot, and it's capturing the odometry data of the robot. Yeah, specifically, it's capturing the values of the position of the robot in the X and Y coordinates. Yeah? So far, so good. Are you guys following? Have you been able to read the position of the robot from your web page? Is it clear? Kevin, Koichi, Birwinder. Are we good to continue? Yes? Yes. Okay. Then let's keep going. All right, so first step is done. We have been able to establish the connection with the robot and to capture odometry information from the robot, okay? However, it is a little bit cumbersome to have to be moving the robot here and then changing to the web page to see the updates, yeah? So I think it would be much better if we can move the robot directly from the web page, right? Okay, then let's do that. So next step is we are going to add a joystick, a virtual joystick to our web page in order to be able to control the robot from the web page instead of having to run the teleop twist keyboard program here from a terminal, okay? I think that would be much cooler. So let's go with that. Then, for this, we are going to use a specific library, which is nipple.js, okay? You can have a look in case that you want to see more details here. You have a specific link to the source code, okay? But basically, this is going to allow us to very easily add a virtual joystick to our web page, okay? So what we need to do, first of all, we need to import this library, yeah, like this. Then, second, we need to set up a new topic, which is the command bell topic, right? Because in order to move the robot, the topic that we use is the command bell topic, right? ROS2 topic list. Yeah? Command bell topic. Yeah, this is the topic that we use in order to move the robot. Yeah, so we have to define this new topic, command bell topic, specifying the name of the topic and again the type of message used, which is twist messages. Okay. Then we define some new variables. We define a new function for setting up our joystick, which we have here, and inside this function, basically what we are doing is to position our joystick in the web page, and then here we have some functions, basically two. We have one function for when we are moving the joystick, yeah, and basically we are mapping the movement of the joystick, we are mapping the position of the joystick with a specific twist message, okay, using these functions here, yeah. Depending on where we are moving the joystick, we are going to be sending a specific twist message, yeah? And once we have our twist message, then what we do is to use the publish function in order to publish the message into the command bell topic, yeah? And we have a second function here, which is end, which is whenever we stop moving the joystick, then we are going to stop sending velocities. Actually, we are going to set the velocities to 0 in order to stop the robot. Yeah? Then we add, using a div, we add the joystick to our web page, and then here we have some more CSS styling to make it look cooler. Okay, like a background color and some borders, etc. Okay? So the final result is going to be, again, this. So let's copy the final result, the whole code. Let's copy it and let's paste it into our web page. So again, I'm going to remove all these and paste my updated code. Yeah? So we are importing the nipple.js. We have here some CSS styling for our joystick container, yeah? We are adding here the joystick container class, and we have the new command bell topic defined, and the new setup joystick function defined here, yeah? So let's refresh our web page. Let's refresh our web page like this. There we go. Then here we have our joystick appearing and the position here at the right side. So again, I need to reestablish the connection with my web page. So let me introduce the rosbridge address. So let me copy here the rosbridge address, paste it, and connect. And as soon as I connect, you're going to see some colors here appearing here in the joystick. So now, if I move, let me bring up the simulation here. If I move the joystick by pressing and dragging, yeah, the robot is going to move in the simulation. For instance, let me move it backwards a little bit, and let me switch quickly here to the simulation. See? Yeah? Actually, let me try to do something. Let me see if I can do this. I'm not sure if I'm going to be able to do this. Can you see the web page like this? Can you see the web page here or not? Can you see the web page now? I have basically, no, says Kevin. Okay. Yeah, because I am trying to put it side by side with the simulation, but I think it's not showing. Okay. No problem. I'm going to put it back again to, yeah, no problem. Let me put it back here. Okay. So yeah, now you can see it again, right here. So let me reestablish the connection. Here we go, connect, okay. Yeah, so we can see like this for now, yeah. So I move back and the robot moves back, yeah. I move the joystick forward and the robot moves forward, as you can see, yeah. If you move it to one side, the robot is going to start rotating to the side, as you can see right there, okay? Yeah? Yeah? Okay, awesome. So now we have a joystick in order to be able to teleoperate our robot from the web page using a very convenient joystick. Right? Of course, you can also see that while moving the robot, the odometry data of our robot is updating also. Right? Okay. On my web page, says Kevin. Okay. So have you guys been able to add the joystick to the web page? Yes? No? We have one final step. Okay, we are almost there, which is the bonus. Okay, which is going to be really cool. So, have you guys been able to add the joystick to your web page and teleoperate the robot using the joystick? Yes? Now it's working, says Kevin. Okay, awesome. Then, as you can see, it is a little bit painful to have to move the robot here from the joystick and then going back to the simulation to see if it's really moving. Yeah, it's not very convenient. Yeah, not very good. So, what if we do something? We know, yeah, from when we run the ROS to topic list command, if you remember, yeah, ROS to topic list, we know that there are some topics from the camera, yeah? So what if we add a camera display to our web page so that we can see what the robot is seeing in real time? That would be really cool, right? Then let's do this, okay? Actually, this was supposed to be some homework, but I'm going to do it here with you, okay? So the final result should be something like this, where we have the joystick, the camera feed of the robot here, and also the position using the odometry data, yeah? Then with what we have done so far, we should be able to solve this, right? What would we need to do? So first of all, we need to set up an image topic using the camera topic, specifying the camera topic name and specifying the type of message used, as we have been doing so far. Yeah. Second, we need to subscribe to the topic and add a function callback, similar to what we did with odometry. Yes, but in this case, we have to show the images in a element of our web page, right? And then add to our web page this element. Yeah? Then with what we have learned so far, you should be able to more or less solve this, okay? In any case, for this class, I'm going to show you again the final code, yeah? So this is how the code should look like. So again, we can copy this and paste it into our web page. I'm going to do this so far. And then I'm going to show you here what we have done. So let me remove and paste the updated code. There you go. So what do we have here? Let's see what we have added. Okay, so basically we have some new styling here, yeah, for the image view, as you can see. Then we are adding the image view class here also to the body of our web page, right? And then inside the JavaScript section, inside the script tag, we are adding a subscription to the image topic. Yeah, first of all, we define the image topic, providing the topic name and the type of message used. And then we subscribe, yeah, we use the subscribe, same as we did for the telemetry. We subscribe to the image topic, and then we put the data, capture it from this topic, and we show it in an element of the page. In this element, which is camera feed. Yeah? Here we have the joystick, nothing new. Yeah? So what is this going to look like? Let's see. Let me refresh my web page here, and let's connect using the rosbridge address. Let me copy the address here and connect to my robot. Connect. And voila. Here we have our web dashboard with the joystick to move the robot around. The camera feed, the live camera, real-time camera feed of our robot, and the position data of our robot. So now we can teleoperate our robot and move around the environment like this and see what the robot is seeing in real time, right? So let me try to move like this. Going to try to access here to the other room. There we go. Yeah, of course, if we go to the simulation, we are going to see that our robot is moving, right? Yeah, it's entering this other room here, right? And here we have our other robots. Yeah? Well, my robot seems like it went up. Okay, there we go. It recovered it. Yeah. Okay, so now we have a very basic, but it is something usable, right? It is something to get started with. We have a joystick to control the robot, a camera feed to see what the robot is seeing, and some information about the position of our robot, yeah? Without having to use RVs or developer tools, yeah? So we can provide this web dashboard directly to our end client, and he's going to have something that he can use very easily without having to launch RVs and any developer tools, right? Yeah? Has everybody been able to reach? Birwinder say, this site can't be reached on my web page. What do you mean, Birwinder? I don't get what do you mean by it can be reached. So others, Kevin, Koichi, Ume, have you guys been able to add the image display to your web page? Kevin says, all working cool. This site can reach of joystick page. So your joystick is not working, Birwinder, you say? Okay, so if something is not working, probably it's because... So two options. Either you copied and pasted something wrong here from the code. Okay, maybe you didn't copy and paste the code properly. That is an option. Another option is that you are not connected. Okay, so make sure that you establish the connection. Okay, if you are connected with the ROS bridge here properly, you should be able to use the joystick, as you can see, without any problem, okay? So verify this. All right, guys, then I'm going to basically leave it here. We have reached the end of the class. Down here, I have left to you a link to our course on web interfaces for ROS, where we cover these topics and much more, okay? So you can see here everything, all the different topics that you are going to learn with the course, and clicking on the image, this is going to take you directly to our course in case you want to check it, okay? So yeah, I'm going to leave it here. I hope that you enjoyed this class. Oh, Kevin says, that happened to me as well. I refresh it and try to connect again. Okay. Yeah. Yeah, so probably you lost the connection or something like this. No, not a big deal. All right, guys, then I'm going to leave it here. Thanks again for being here with me today. I hope that you enjoyed the class. I hope that you learned something new. And yeah, hope to see you all in the next one. And as always, until then, keep pushing your ROS learning. Bye-bye.